Hi, this is Mr. Manley. In this video, we're going to look at sum and difference formulas for sine and cosine. There's also sum and difference formula for tangent, but we're just going to look at sine and cosine for this video. First off, we see the formula here, and this would be on any trig formula sheet. The formula for both sum and difference of angles, if I'm taking the sine of them. And notice this plus and minus here. And the idea here is that if I'm doing an angle plus an angle, then I'm going to have sine u cosine v plus sine v cosine u. And if I'm doing minus an angle, then I'm going to also have minus. And that's important more when we compare it to cosine. For with cosine, if I do the sum of two angles, u plus v, and then I look at the formula, cosine u cosine v, it's going to be minus sine u sine v. And then if I have the difference of two angles, u and v, then it's going to be cosine u cosine v plus. So the signs switch. But here, starting off, we're looking at sine. And initially, I just want to apply it just like we would if we were simplifying a trigonometric expression, or maybe if we had a proof to do, we could use this formula. But we'll look at simplifying an expression. Simplifying this expression using the trigonometric identity of a sum formula. See if you understand how this formula is going to be used. This is my u is x, and my v is 3 pi. And then from there, it's really a simple substitution, right? So I can say that the sine of x plus 3 pi is equal to sine x cosine 3 pi plus the sine of 3 pi and the cosine of x. And that's just a substitution. Within this expression, I have some things that I can evaluate here. I can evaluate cosine of 3 pi. I can evaluate sine of 3 pi. Looking at a unit circle, the cosine of 3 pi, if I go around pi, 2 pi, 3 pi, I'm going to get xy coordinate of -1, 0. And what's cosine on a unit circle? It's the x coordinate. So the cosine of 3 pi is -1. I can just write sine x times -1 plus sine of 3 pi, ending up at the same place. And using those xy coordinates, what's sine on a unit circle? It's the y coordinate. So the sine of 3 pi is 0. And that'll zero out this whole term, right? 0 times cosine x. So we just drop that. And that's it. I've used the sum formula for sine to simplify the sine of x plus 3 pi to negative sine x. Okay. Let's look at the application in another light. This is interesting because the sine of 15 degrees is not a value that I know. 15 degrees is not on a unit circle. So where I would be headed with this would be perhaps a calculator. But using the sum formula, I can find a way of writing 15 degrees that I can evaluate. Consider that the sine of 15 degrees is equivalent to the sine of 60 degrees minus 45 degrees. See that? And then, using the sum formula, or actually I'm going to be using the difference formula in this case, because I have a subtraction sign. Using the difference formula, I can say sine of 60 degrees cosine 45 degrees minus sine of 45 degrees cosine 60 degrees. And I know all these values from the unit circle. The sine of 60 degrees is rad 3 over 2. Cosine 45 degrees is rad 2 over 2. Sine of 45 degrees is rad 2 over 2. Cosine of 60 degrees is 1/2. And I was able to evaluate all those and now have a numerical expression, a numeric expression. Simplifying, what do I get? Rad 6 minus rad 2 over 4. Don't need to simplify that anymore. Okay, let's look at another one. Getting back to cosine. Say I want to know what's the cosine of 7 pi over 12. Again, that's not an angle I know. I only know multiples of pi over 2, pi over 3, pi over 4, and pi over 6. I don't know multiples of pi over 12. So maybe I'm left with the calculator. But could I write this as a sum or difference of angles? Two angles that I do know. I actually think that's a little difficult, at least for me, to think of it in terms of radians. So I'm going to convert it to degrees. I hope it's very simple for you to think of how to convert radians to degrees. 7 pi over 12 times 180 degrees over pi, and then simplify that. And it simplifies to 105 degrees. Now, it could be that that's simplified to something that we couldn't work with. It's a possibility. But 105 degrees we'll be able to work with. Cosine of 105 degrees. Now, talking in degrees, is there a sum of two angles that I know that are more convenient, or that I can use the unit circle for? And of course there are. Cosine 60 degrees plus 45 degrees. And then going into the formula above, I would say cosine 60, cosine 45. Opposite sign, remember. If I have addition, this sign's going to be subtraction, as we can see in the formula. If I have addition, this sign's going to be subtraction. And that'll be the sine of 60 degrees and the sine of 45 degrees. And of course these values, I know all of these values from the unit circle. Cosine of 60 degrees is 1/2. Cosine of 45 degrees, rad 2 over 2. Sine of 60 degrees, rad 3 over 2. Sine of 45 degrees, rad 2 over 2. And we can simplify that to rad 2 minus rad 6 over 4. And that's it. So those are your sum and difference formulas for cosine and sine. And we do have one for tangent. Really no different. You're given the formula. You are going to try and work with angles so that you can find angles that you know the trig values of, if possible. And then you just plug into the formula.